So in the last topic of electrostatics, there'll be some demonstrations, and I'll be demonstrating charging by induction. So for all of these demos, we need something called an electrophorus. As you can see, it's basically a slab of plastic on top of wood. You rub this thing with the wool. You can see my hand there. That makes the wool positively charged, and that plastic becomes negatively charged. So here's the same thing on the diagram. Now the next step is you touch this with a metal plate with an insulating handle over here, and that picks up the negative charge, making that plate negative. Next, the plate is made to touch the top of an electroscope. So that thing you see there, sort of like a clock dial, that central black part, that is stationary. That aluminum needle-like thing in the middle, that can move. So when it's at the 12 o'clock, 6 o'clock position, that indicates zero charge. So we'll touch the metal plate to the electroscope and cause it to become negatively charged, and you'll see a deflection. And there's the deflection, as you can see. If that plate is recharged with some fresh negative charge and you bring it close to the electroscope, you'll see that the deflection increases a little bit, showing that on the electroscope and on that plate, you have the same sign charge, in this case negative. The next important step is to charge the plate by induction. So the plate is brought close to the plastic, but it doesn't touch it. So the negative charge of the plastic pushes the negative charges out of the metal plate. When my finger touches the metal plate, they enter my body. So that metal plate ends up with a positive charge. So this is a way to charge a piece of metal with the opposite sign without removing any charges from that plastic slab. So let's look at the diagrams again. So here they are. First you charge the thing by rubbing the plastic. Then you bring a metal plate in contact with it. This is charging by conduction. The charge simply transfers from the negative plastic to that metal plate. So you have the same sign charge. That's the first step. Then we charge the thing by induction. This is a still that I just showed you. So here you bring the metal plate close to the plastic, but don't touch it. So the negative charges cannot get transferred to the plastic. However, they tend to push the negatives away. So when you bring a finger in contact with it, like over here, the charge enters the finger and you're left with net positive charge on that plate. Now, how can you prove that you have an oppositely signed charge on here, a positive and not a negative? You can bring it close to the electroscope, and that electroscope this time, because you have the opposite charge, it'll decrease the deflection instead of increasing it. And here's a still picture of what we just talked about. You bring the positively charged plate close to the electroscope and the deflection decreases. So now let's watch a video of all of this happening. So there's the plastic being rubbed and charged the first time. Here's the metal plate picking up that negative charge directly by contact. So this is conduction. You bring it close to the electroscope, transfer charge to it. It settles down with a deflection. Now you bring a negative plate close to it again. See, the deflection increased a little bit. Now you repeat this process. This time you charge the plate by induction instead of conduction. You see the plate is brought close but no contact. You touch the plate with the finger. The positive, the negatives get pushed out into the finger. See, when the plate is brought close to it, you can see that the deflection is basically decreasing. So this is a quick demo of charging by induction versus conduction.